Now we are asked, what pressure does a column of air in Herzstein amphitheater... Now we're asked, what pressure is created by a column of air in Herzstein amphitheater? It's 10 meters tall, and what pressure on the floor is just due to the air in the amphitheater? That's the question, and the density of air given is 1.28 kilogram per meter cubed. So the pressure in a fluid, the hydrostatic pressure, as we call it, really is just the weight of the fluid. So you could just calculate the weight from the density and say it's the weight, and that's really all it is. But let's just do our hydrostatic formula, just get some more practice using it. Right? So what we're thinking about is here, is Herzstein amp, here's the bench, here I am standing here blathering on, and we have a column of air, and what pressure is created down there. So remember, if you want the pressure in some fluid, it's the pressure at the top of the fluid plus rho g, the height of the column. Often we put atmospheric pressure here because it's usually a column of liquid with atmospheric pressure on top. Here, there's sort of atmospheric pressure there. So the full question clarifies, okay, we don't care about the atmosphere pushing on this column of air. We just want to know what's created by the column of air. So in this problem, we're saying we don't care about that. We're ignoring that. We just want to know what's created by the column of air. So for that, it's this formula, rho gh, which we derive just from the weight. Again, you could just get the weight of the air. Anyway, but let's not do that. Let's plug in here. Let's see, the density of air, 1.28 in MKS units. Gravitational constant, 9.8 meters per second squared. I'm not putting in units. And it's not the gravitational constant, it's the acceleration due to gravity at the surface of the Earth. And h, that's just the height of the column, which we were told is 10 meters. So you really just multiply those three, and you get, what do you get? 10, almost 10, 2 decimals over. Actually, if you run the numbers, you get 125 newtons. Per meter squared. Also known as 125 pascals. I did that in summary. 125 pascals. So you see the pressure isn't like nothing due to the weight of the air. We often think, well, the air doesn't weigh anything, don't worry about the weight of the air, but it actually does weigh something. And here, this number, 125 pascals, sounds like kind of a lot, but really if you think relative to atmospheric pressure, 101,325, it's not that high. And the reason I wrote newtons here is I was thinking we could say, wow, 125 newtons sounds like a lot of weight from air, but that's over a meter squared. Right? So it's a pretty big area all the way up 10 meters. So air doesn't weigh nothing, but it doesn't weigh much.